Hi guys, welcome to this easy maths video where today we will be looking at the predicted paper that I've prepared for the Edexcel GCSE Maths Paper 2 higher tier. This is a calculator paper. It's made up of 80 marks, which is the same for all three papers. Now I've tried to include as many topics that we didn't see in paper 1, and hopefully this should give you quite a good indication of what topics you could see coming up in paper 2. Question 1 says a group of n children are taken to the theatre. For each child, the cost of travel is X pence and the theatre ticket costs 3 times as much as the travel. Each child is given an ice cream which costs 50 pence less than the travel cost. The total cost for the group of children is C pounds. Find a formula for C. Okay, so if we break this problem down, the first thing we know is that there's n children and that the cost of travel is X pence. Okay, so that means we're going to have C, which is going to be equal to nx, because n children are going to buy tickets which cost X pence. Then we're told that theatre tickets cost 3 times as much as the travel. Well, if the travel cost X pence, then each theatre ticket is going to cost 3x pence. So it's going to be plus n 3x. And then this last bit, we're told that each child is given an ice cream which costs 50 pence less than the travel cost. Now, we've got to be slightly careful here. We know that the ice cream is 50p less than the travel cost. So if it's 50p less than the travel cost, and C is actually in terms of pounds, then we're going to have to convert 50p into pounds. So it's going to be 0.50. So they're going to buy n ice creams, which cost X minus 0.50. And if we simplify this, we're going to get 4nx. Then if we expand the brackets, we're going to get n times x, so that's going to be plus nx. And we're going to get n times minus 0.50, which is minus 0.50n. And then if we simplify this, we're going to get 5nx minus 0.50n. And then what we can do here is we can factorise out an n. So we get n multiplied by 5x minus 0.50. And that is our answer for part A. Part B says if the total cost was £1,180 and the travel cost £6 per child, how many children went on the trip? Okay, so we need to use this formula again. So we know that the total cost is 1,180, so that's going to be C. Now n represents the number of children. That's what we're trying to find, so we'll leave that as n. And x, if you remember, is the travel cost. And we're told that the travel cost per child is £6, so it's going to be 5 multiplied by 6 minus 0.50. Now we can simplify everything in the bracket, because it's just 5 times 6, which is 30, minus 0.50, which is 29.5. So we're going to get 1,180 equals 29.5n. And then we can divide both sides by 29.5 and we'll get our value for n. So n equals 1,180 divided by 29.5. And if you type that into your calculator, you will get an answer of 40. So that is part B. Question 2 says look at the following sequence. We've got to write down the next term in the sequence. So we've got the terms 2, 5, 10, 17 and 26. So if we zoom in on this, to go from 2 to 5, we're adding 3. To go from 5 to 10, we're adding 5. To go from 10 to 17, we're adding 7. To go from 17 to 26, we're adding 9. Now, what's going to happen here is we've actually got a second difference between the first difference, because each of these terms are going up by 2. So what that means is the next term of the first difference is also going to go up by 2. So we're going to add 11. So that means we're going to have to add 11 to 26 to get the next term in the sequence. So we're going to do 26 plus 11, which is 37. And that is the next term in the sequence. Now part B says work out the nth term of the sequence. Now what I'm going to write this sequence out again. what we can do is we can compare it against a sequence that we already know. So because we know that this has a second difference of 2, it must be a quadratic sequence. So we know that all quadratic sequences with a second difference of 2 all start with n squared. So the sequence for n squared is just the list of square numbers. It's 1, 4, 9, 16, 25. But what we should be able to see is that the terms for n squared are all just one less than the terms for the sequence that we're looking at. So what we've got to do is we've actually got to add 1 to n squared. And that will give us each of the terms in the sequence. If we substitute 1 into n squared plus 1, we get 1 squared, which is 1, plus 1, which is 2. Then the second term is 2 squared, which is 4, plus 1, which is 5. And then the third term is 3, 3 squared is 9, plus 1 is 10. And so on. So we can see that the sequence satisfies the nth term of n squared plus 1. Our final answer. And then part C says work out the 12th term of the sequence. Well, we can just use the formula n squared plus 1. Then we just need to replace n with 12. So we get 12 squared plus 1. 12 squared is 144. Plus 1 is 145. And that is question 2. Then question 3 says a computer operation takes 36 seconds to the nearest second. Immediately after the operation finishes, a second operation starts. The second operation takes 19 seconds to the nearest second. Calculate the upper bound for the total time taken to complete the 2 operations. Okay, so if we need to calculate the upper bound, we need to work out what the upper bound of the first operation is and what the upper bound of the second operation is. So if each of the operations have been rounded to the nearest second, that means the upper bound for the first operation is going to be 36.5. Because the nearest second means 1 second, we divide that into 2 separate parts, so we get 0.5 seconds. And then we add 0.5 to 36 to get the upper bound, and we subtract 0.5 from 36 to get the lower bound. So we can apply the same principle to the second operation. So the upper bound for that is going to be 19.5. So the upper bound for the total time taken to complete the 2 operations will be 36.5 plus 19.5, which gives us an answer of 56 seconds. Question 4a, part I, says simplify the following. We've got s to the power 9 multiplied by s to the power of 8. Well, this is just our laws of indices. So when we've got 2 terms with the same base but different powers, we add the powers. So s to the power 9 multiplied by s to the power of 8 is going to become s to the power of 17, because we're adding 9 and 8 to get 17. So that's s to the power of 17. Second part says simplify h to the power of 8 divided by h to the power of 4. Well, when we're dividing, we subtract the powers, so we're just doing 8 minus 4, which is h to the power of 4. So that's the second part. And then part B says expand and simplify 2 all multiplied by 4x plus 3 plus 4 all multiplied by 5x plus 2. So if I write that out, we're going to expand the brackets, so we're going to have 2 multiplied by 4x is 8x, plus 2 multiplied by 3 is plus 6, plus 4 multiplied by 5x is 20x, plus 4 multiplied by the 2 is plus 8. Simplify this, so we collect like terms, so we do 8x plus 20x, we get 28x, and then we can add the 6 and the 8, and we get 14. So it's 28x plus 14. Part C says expand and simplify x plus 2 all multiplied by x plus 4. Okay, because we're multiplying 2 x terms, we're going to end up with a quadratic equation. So we're going to have x times x, which is x squared, x times 4, which is plus 4x, plus 2 times x, which is plus 2x, plus 2 times 4, which is plus 8. Simplify the x terms, we get x squared plus 6x plus 8. Question 5 says Rhea buys a van for £9,500 plus VAT at 20%. Rhea pays a deposit for the van. She then pays the rest of the cost in 12 equal payments of £665 each month. Find the ratio of the deposit Rhea pays to the total of the 12 equal payments. Give your answer in its simplest form. Okay, so what we can do is we can work out the total cost of the van by first working out VAT charged on the van, so that's going to be £9,500 multiplied by 20%, which is £1,900. We want to add that onto £9,500, so we're going to get 11,400. Then we're told that Rhea pays a deposit for the van, and she then pays the rest of the cost in 12 equal payments of £665 each month. So we need to work out how much the deposit cost. And what we can do is we know what the total cost is, and we can work out the total amount that she has paid from the monthly instalments. So we can work that out by doing 12 times £665, which gives us £7,980. And then to get the deposit, we just need to do 11,400 subtract £7,980, which is 3,420. Now the question says find the ratio of the deposit Rhea pays to the total of the 12 equal payments. So it's the ratio of the deposit to the 12 equal payments. Well, the deposit we've just worked out, which is 3,420, to the 12 equal payments, which we've worked out, which is 7,980. We've got to give this as a ratio in its simplest form. So what we can do is, on your calculator, if you just do 3,420 divided by 7,980, it will give it as a fraction in its simplest form, which is 3/7. So we can just write that as a ratio as 3:7. So that is our final answer for question 5. Question 6, 25 students in Class A did a science exam, 30 students in Class B did the same science exam. The mean mark for the 25 students in Class A is 67.8. The mean mark for all the 55 students is 72. Work out the mean mark for the students in Class B. Okay, so the formula for working out the mean in this case would be taking the total number of marks, dividing it by the number of students in each class, and that will give us the mean mark within that class. So if we look at Class A, Class B, and then here if we just call this total students, we can look at each of the cases separately. So Class A, what do we know? Well, we know that there's 25 students and we know that the mean mark is 67.8. So if we use a formula for the mean, so that's going to be the total number of marks. Now we don't know what that is, so I'm just going to call that total marks. If we divide that by 25, that's going to be equal to 67.8. So if I just move this over slightly, what I can do is I can multiply both sides of this formula by 25 so I can work out the total marks. So the total marks is going to be 25 times 67.8. And if you work that out on your calculator, you get 1,695. So what you should be able to see is I can actually do the same for the total number of students, because I know that there's 55 students in total and the mean mark is 72. So if we say that total marks divided by 55 equals 72, that means the total marks is going to equal 55 times 72, which simplifies to 3,960. So now I know the total number of marks for class A, I know the total number of marks for both of the classes. Well, that means I can work out what the total number of marks is for just class B. Their total marks is just going to be 3,960 minus 1,695, which is 2,265. Now to work out the mean, well, that's the total number of marks for class B, which we've just worked out, is 2,265, divided by the total number of students for class B, which we know is 30. So it's going to be 2,265 divided by 30, which gives us 75.5. That's our final answer for question 6. Question 7. Here is a scale drawing of a rectangular field ABCD. Peter is searching for treasure buried in the field. He knows it is at least 4 meters from the point B, nearer to CB than to CD, and less than 5 meters from AB. On the diagram, show the region that the treasure could be found in. Okay, so it's going to be a little bit tricky because I can't actually use a compass on here, but I'll try and give it my best shot so you can sort of see what it will look like. So the first part says that the treasure is at least 4 meters from the point B. So the point B is up here, and we're told the scale down here that 1 centimeter represents 1 meter. So that means that if you get your ruler, and I can use a ruler here, that 4 meters we can measure as 4 centimeters. So from point B, mark a dash there, so that would be here, and then I'll try and join it up with an arc. Now, and of course you would do this with a pair of compasses. You would take your compass, measure it with a distance of 4 meters, and then draw an arc. I don't have a compass here, so I'm just going to have to try and draw an arc as best as I can. So that's something like that. That looks okay. And then second part says, treasure is nearer to CB than to CD. Now, what that means is we're going to have to do an angle bisector. Now, when we do an angle bisector, we can take our compass and make it any distance we like, as long as we don't change the distance of our compass when we're drawing in our construction lines. So I want to draw my arcs from point C. So let's say I draw the first arc here, and then I want to draw the second arc along the line CB, and it's got to be the same distance from CD, so I'm going to say that's probably about there. Then what I will do is I will place my compass on each of these arcs. So if we start from the arc on CD, I am then going to draw another arc which is somewhere within this region. So it's going to be the same distance. We'll probably end up getting an arc roughly here, and then from the point on CB we'll get an arc somewhere here. Okay, so then what you're going to do is you're going to draw a straight line going from C through to the intersection of those 2 points, and you'll get a line that looks something like that. As we know, that this is all quite rough because I don't have a pair of compasses, but I'm just trying to give you a general outline of what your construction line should look like. And then the last part says that the treasure is less than 5 meters from AB. So here you can get your ruler and you can measure 5 centimeters on the line AD, that's just here. And then if I do the same for the line BC, that's going to be just down there, and then you want to connect those 2 arcs together. So we get something like that. Okay, that line isn't particularly straight, but that looks okay. So now we need to shade the region that the treasure could be found in. Well, if it's at least 4 meters from the point B, it's going to be further than this arc, which we drew here. and then nearer to CB than to CD, well, that means our region needs to be above the angle bisector that we just drew. So everything above this line here, and then it's less than 5 meters from AB. Well, that was this line that we drew here. So the region, if I shade this in red, should be this region here. And that is our final answer. So question 8 says the diagram shows a dirt bike track. The length of each straight side is 45 meters. The radius of the semicircle at the end of each straight side is 19 meters. Hardeep rides around the track once. His dirt bike has wheels which have a diameter of 58 centimeters. Calculate the number of times each wheel will rotate as he rides around the track. Okay, so what that means is we will need to work out the perimeter of the whole track, and we will need to work out the circumference of each of the dirt bike's wheels. So if we concentrate first on the track, so the perimeter of the track, so to work out the perimeter of the track, well, we can work out the total length of each of the straight sides. So that's easy, that's just 45 plus 45, which is 90. Now we're going to have to work out what the circumference of these semicircles are. Now, and you should know that the circumference of a circle is pi multiplied by the diameter. Or, because the diameter is twice the radius, we could write it as 2 pi multiplied by the radius. What you should be able to see is that these two semicircles at the end both have the same radius. So what that technically means is if we combine these two semicircles together, we've just got one whole circle. So what we can do is we can actually work out what the circumference is of the whole circle by combining these two semicircles together. So what's going to happen, we're actually going to end up with one circle that has a diameter of 2 times 19, which is 38 meters. So that means the circumference of this circle, which is the same as the circumference of those two semicircles, is going to be 38 pi. Now, the perimeter of the track would be taking the circumference of those two semicircles and adding it to the straight sides of the track, which were 90 meters in total. So the total perimeter, so if I call that P for perimeter, is going to be 90 plus 38 pi. Okay. Now we need to think about the circumference of the dirt bike wheels. Okay, so if I draw another circle, now we're told that the dirt bike wheels have a diameter of 58 centimeters. Now remember, this track is in meters, so we want to convert 58 centimeters into meters. When we know that there's 100 centimeters in a meter, so this would be 0.58 meters for the diameter. Now remember, the circumference of a circle is pi multiplied by the diameter, so this circumference, if I call it C, is going to be 0.58 multiplied by pi. Okay, so now I've got the total circumference of one of the dirt bike wheels, and I've got the total perimeter for the track. So in order to work out the number of times each wheel will rotate as he rides around the track, we're going to have to take the total perimeter and divide it by the circumference of one of the dirt bike wheels. So that's going to be 90 plus 38 pi, all divided by 0.58 pi. You should get an answer of 114 0.91, that's to 2 decimal places. Now what I'm going to do is I'm going to round that up to the nearest whole number, so we can say he has rode around the track 115 times. That's our final answer for question 8. Question 9 says Ranjit invests £4,000 at 1.8% compound interest per annum for 3 years. Part A says work out the value of Ranjit's investment at the end of the 3 years. So he starts off with £4,000, and we're going to increase his account by 1.8% interest at the end of each year. So to increase £4,000 by 1.8%, we're going to multiply it by 1.018. Because what we're doing is we're taking 100% of £4,000 and then adding 1.8% of that £4,000. Now that's going to happen for 3 years, so we're going to raise this to the power of 3. So we can work that out on our calculator, and we end up getting an answer of £4,219.91. That's to 2 decimal places. So the second part says Seisha, if I'm pronouncing that right, invests £18,000 in a variable rate compound interest account. The interest she receives is 3% for the first year, 2.5% for the second year, 1.5% for the third year. Work out the value of Seisha's investment at the end of the 3 years. Okay, so if we look at the first year, she starts off with £18,000. She receives 3% interest on top of that £18,000. So we're going to multiply it by 1.03. So if you work that out on the calculator, we get £18,540 at the end of the first year. Then we look at the second year. Well, she starts off with 18,540, and that gets increased by 2.5%. So we can multiply it by 1.025. So if you work that out on your calculator, you're going to get £19,003.50. So we now look at the third year, and they start off with £19,003.50. Multiply that by 1.015. Work that out on your calculator, and you get £19,288.56 to 2 decimal places. So that is our final answer. Question 10 says x and y are both integers. On the axes below, mark with a cross each of the points which satisfy all of the following inequalities. Okay, so if we look at the first one, which is basically saying that x is greater than minus 2, but it's less than or equal to 1. So for this, we actually need to draw 2 separate lines. We need to draw the line x is greater than minus 2, and the line x is less than or equal to 1. So the line x is greater than minus 2 is the line that goes through the point x equals minus 2, which is parallel to the y-axis, and that's going to be a dotted line because we don't have a strict inequality. Okay, and what I'm going to do, I'm going to shade away for the region that we don't want. So we don't want any values of x which are less than minus 2. So that's going to be this whole region behind here. Okay, and then we're going to have x is less than or equal to 1. So that's going to be the line which goes through the point x equals 1, which is parallel to the y-axis. But this time, because we've got a strict inequality, it's just going to be a solid line. And it's going to look like that. Now and again, we're going to shade away from the region that we don't want, so that's all the values of x which are going to be greater than 1. So that is this whole region here. Now, and if we look at the second inequality, which is y is greater than minus 2, well, that is the line y equals minus 2. It goes through the point y equals minus 2 and it's parallel to the x-axis. Now, and it's going to be a dotted line because we don't have a strict inequality, so it's going to look something like this. Now, we're looking at all the y values which are greater than minus 2, so we need to reject all the y values which are smaller than minus 2. So that is going to be this whole region down here. And then if we look at this last inequality, which is y is less than x plus 1, well, again, that is just the line y equals x plus 1. Now, the line y equals x plus 1 has a y-intercept of 1, so it's going to go through this point here, and it's also got a gradient of 1. So that means for all of the points on that line, we're going to go 1 unit right, 1 unit up, 1 unit right, 1 unit up. So the line is also going to intersect the x-axis at minus 1. So you should get a straight line. And remember, this line is also going to be dotted because it's not a strict inequality. So you've got to be a little bit careful here. So it should look something like that. And then we want all the y values that are less than x plus 1. So we want to shade away from this region up here. So on this graph, we need to mark with a cross each of the points which satisfy those three inequalities. So you should be able to see that it's going to be, if I mark it with a red pen, it's going to be that point there, and that point there. So if I mark those as coordinates, call them A, B, and C. A is going to be the origin, 0, 0. We'll call that B, which is going to be 0, minus 1. And we'll call this C, which is going to be minus 1, comma, minus 1. And that is question 10. Question 11, John says that there are no solutions to this inequality. X squared minus 3 is less than minus 2. Is John correct? Explain your answer. So in order to solve an inequality like this, we've got to take the minus 2 and move it from the right hand side to the left hand side. So if I write the inequality again, we're going to have x squared minus 3 is less than minus 2. We're going to add 2 to both sides. So we get x squared minus 1 is less than 0. Now, you should be able to see on the left hand side, we've got a difference of two squares. So this will factorise to x plus 1 multiplied by x minus 1, which is less than 0. So now, if I just do a little sketch of that graph, you should recognise that it's going to go through both the points x equals minus 1 and x equals 1. And it's going to be a parabola. So it's going to look something like this. Now, we're interested in all the x values where y is less than 0. So if I shade that on the graph, that's going to be all of these values here. All of the x values which are below the y-axis. So we can write that as an inequality by saying that x is greater than minus 1 but less than 1. So we can write it like that. So our response to John is no. John is not correct, as the inequality has solutions between minus 1 and 1 for x. And that should get us both of the marks. Question 12 says the table below shows some information about the students in the sixth form. Milo is going to carry out a survey of these students. He uses a sample of 50 students, stratified by gender and year group. Calculate the number of year 12 boys that should be in his sample. Okay, so we want to include the year 12 boys within our sample. So there's 38 year 12 boys out of the total of 169 students, and we want to take a sample of 50. So we're going to do 38 over 169 multiplied by 50. And and that becomes 11.2426, so on. Now we can't have 0.2426 of a student, so that we're just going to take a sample of 11 boys from year 12. So the answer is 11. Question 13 says the incomplete histogram below shows the length of time in minutes taken by students to complete a maths test. We've got to use the histogram to complete the table below. Okay, so we've got the time and we've got the frequency, and the histogram plots time against frequency density. So the key to this question is knowing the formula for frequency, and that is frequency equals the frequency density multiplied by the class width, which is just the width of each of the bars on the histogram. Looking at this graph, frequency is the area of each of the bars within the histogram, because we're taking a value for frequency density and multiplying it by the class width, which is what our formula is for the frequency. Now you'll see that along the x-axis we've got a scale for the time, but along the y-axis we don't have a scale for frequency density, so we're going to need to work that out before we can work out any values in the table. So the way we can do that is we can look at two values in the table where we've got the class width for time and an amount for the frequency. So we look at the second line where the time is between 30 and 40 minutes and we've got a frequency of 35. Well, that is the second bar on our histogram. Now, we can work out the frequency density by taking the original formula, frequency equals frequency density times class width. We can rearrange it to get frequency density, which I call FD, is equal to frequency divided by class width. So, in this case, we know the frequency is 35, and the class width is going to be 40 minus 30, which is 10. So we can say in this case, the frequency density is equal to 35 divided by 10, which is 3.5. And we can plot that on our histogram. So it's going to be this point here, 3.5. Now what you should be able to see is every square on the graph paper is actually going up by 0.5 units. So this is going to be 0.5, that's going to be 1, that's going to be 1.5, that's going to be 2, that's going to be 2.5, that's going to be 3, and then we get to 3.5. I might as well call that 4. So we should now be able to work out what the frequency is for the first bar. So the frequency, remember, is equal to the frequency density times the class width. Well, the frequency density for the first bar is going to be 1 times the class width, which is just 30. So the frequency just remains at 30. So that's nice and easy. And then for the frequency between the time of 40 and 60 minutes, that's this third bar here, we're going to say that the frequency is equal to 3, which is our frequency density, times the class width, which is 20. By doing 60, take away 40 to get 20. 3 times 20 is 60, so that's going to be our frequency there. And that is our values for the table. Then the second part down here, part B, says use the information in the table to complete the histogram. Okay, so we've got the first 3 bars, so we just need to concentrate on these last 2 bits. So we need to complete the histogram between 60 and 80 minutes. Now that has a frequency of 25, so we need to work out the frequency density. So remember, frequency density will be the frequency, which is 25, divided by the class width, which is going to be 80 minus 60, which is 20. So if you work that out on your calculator, you're going to get 25 divided by 20, which is 1.25. Now 1.25 is exactly halfway between 1 and 1.5. So that is going to be roughly here. And I can shade this in. Now for this last bar, we've got the time between 80 and 120 minutes and the frequency is 15. So the frequency density is going to be 15 over the class width, which is going to be 120 take away 80, which is 40. So 15 over 40 is equal to 0.375. So each of these smaller squares is going up by 0.1 units. So it's roughly going to be here. Doesn't have to be exact, as long as it's not too far out. Okay, and that is our histogram. Question 14 says an appropriate solution to an equation is found using this iterative process. We've got x of n plus 1 equals x of n all cubed minus 3 all divided by 8. The first value of x is equal to minus 1. We've got to work out the second value of x and the third value of x. So what you're going to do is x1 is our initial value of x, which is minus 1. Okay, so what you want to do is you want to type minus 1 into your calculator and then press equals. And what's going to happen is that's going to be stored as an answer in your calculator. So then what you can do is you can type this iterative formula in, where x of n is going to be the answer key. So we're going to do answer all cubed minus 3 all over 8. And if you press equals, you should get an answer for x2, which is minus 0.5. Now on x3, we can get just by pressing equals again. We get an answer of minus 0.390625. And there are our values for x2 and x3. So minus 0.5 for x2, minus 0.390625 for x3. Part B says we've got to work out the solution to 6 decimal places. Okay, so the way you want to do this is you just want to keep pressing equals on your calculator until the number of decimal places doesn't change. So if I keep pressing it until our answer doesn't change, you should see that our value of x approximates to minus 0.3819660113. 6 decimal places. It's going to be 1, 2, 3, 4, 5, 6. So we're going to stop here just after that 6. So our final answer is going to be x equals minus 0.381966. That's question 14. Question 15 says write 0.32756 as a fraction in its simplest form where 7 and 6 are recurring decimals. So the way we're going to do this is we're going to say let x be equal to this decimal, so 0.32, 7's recurring, got the 5 and the 6 is recurring. So what I'm going to do is I'm actually going to expand this decimal. I'm going to write it out in its full form. So we're going to have 0.32. Now, because we've got this 7 that's recurring before the 5, and then we've got the 6 recurring, what's going to happen is 756 is going to keep on repeating itself. Like that. So that's just going to keep on going forever. So what I want to do is, in order to convert this into a fraction, I want to multiply this decimal by a multiple of 10, which will move each of the digits over to the left, so that when I subtract both of the decimals, these 756s that are recurring cancel each other out. So what I need to think is, this needs to be 756, this needs to be 756, this needs to be 756, this needs to be 756. So if I kind of work backwards, that means that this number would have to be a 6 and this number would have to be a 5, and then the decimal point go before the 5. Now, in order to do that, what would I have to multiply x by in order to get that result? Well, at the moment, we've got x equals 0.327, and then we've got the 56756, which recurs on afterwards. So because it's 0.327 that we're interested in, we're going to have to multiply it by 1,000 in order to get the 567 after the decimal point. So we're going to get 1000x equals 327.56. Okay, so I'm going to sort of line these up a bit better. So we're going to have x here and our equals here. And then I can just put zeros in front of these, right? So what we now want to do is, if we call this equation 1 and this equation 2, we can do equation 2 subtract equation 1. So we can do 1000x subtract x, which is 990x. And then we can subtract the 3 from 0, we're going to get 3. Subtract the 2 from 0, we're going to get 2. Subtract the 7 from 0, we're going to get 7. Then we can subtract the 5 from 3, we're going to get 2. And subtract the 6 from 2, we're going to get 4. And then what's going to happen is you should be able to see that all of these 7, 5, 6s are going to start to cancel each other out. And they're all going to cancel out. So then we're just left with 999x equals 327.24. So now we can divide both sides by 999. So we get x equals 327.24 divided by 999. Now, in order to simplify this properly, because we don't want any decimals within our fraction, we're going to need to type it into our calculator. So it's 327.24 all divided by 999. And that simplifies to 303 over 925. And that is our final answer. Question 16 says a bag contains 7 good grapefruit and 3 bad grapefruit. Matthew takes 2 grapefruit from the bag at random without replacing them. Part A says calculate the probability that both of his grapefruit are good. Okay, so what I'm going to do here is I'm going to draw a tree diagram. So we're going to have 2 branches. We're going to have good grapefruit, so I'll call that G, and we're going to have bad grapefruit, which I'll call B. So good grapefruit, the probability of getting that is going to be 7 tenths, and the probability of getting bad grapefruit is going to be 3 tenths. So that's the probability of him taking 1 grapefruit from the bag. Now what's going to happen when he takes the second bit of grapefruit from the bag? Well, the probability that he gets good grapefruit, well, he's taken 1 grapefruit from the bag. So the total number of grapefruit that are in the bag is going to decrease by 1. So we're going to have our probability out of 9 now. And if he's taken a good grapefruit, then 7 is going to reduce by 1 to 6. So the probability is going to be 6 over 9 for good grapefruit. So that means that the probability that he gets bad grapefruit, based on the fact that he's already taken out a good grapefruit, is going to be 3 over 9. Because remember, these two probabilities, the probability of getting good grapefruit and bad grapefruit, add up to a total of 1. So here, the probability that he gets bad grapefruit, given that he's already picked out a bit of bad grapefruit, is going to be 2 over 9. So the probability that he picks out a good bit of grapefruit is going to be 7/9. Okay, so that's our tree diagram. So the question said, calculate the probability that both of his grapefruit are good. So that is these two probabilities here. So that's going to be 7 tenths times 6/9. And if you work that out on your calculator, you're going to get 7/15. Okay, so that's our final answer for part A. Part B says calculate the probability that at least 1 grapefruit is bad. Now there's a few ways you could do this. You could look at the tree diagram and say if he picks out good grapefruit, it's going to be 7 tenths multiplied by the probability that he picks out some bad grapefruit, which is 3/9. Or he could pick out some bad grapefruit first, then some good grapefruit second, or in both attempts he could just pick out bad grapefruit. If we have a look at the marks here, this question is only 1 mark, so there's actually a really easy way we can do this, and it's using this first part. If we know that the probability of choosing 2 grapefruit is 7/15, well, that is the only outcome where he doesn't choose at least 1 grapefruit that's bad. So what we can do is we can just do 1 subtract 7/15, and that means all of the chances that are left over are going to include the outcome of Matthew taking at least 1 bad grapefruit from the bag. So if we simplify that, we're going to get 8/15. So that is our final answer for part B. And then part C says another bag contains 8 good oranges and 4 bad oranges. Molly takes the oranges out of the bag one at a time until a good orange is taken, we got to calculate the probability that Molly takes exactly 4 oranges. Okay, so she keeps taking oranges until she gets a good orange. So that means she's going to choose 3 bad oranges first, and then eventually, on her 4th attempt, she's going to get a good orange. So the probability of getting a bad orange to start off with is 4/12. She picks that bad orange out. She's left with 3 bad oranges out of 11 oranges. Okay, so that's after her 2nd attempt. Now she comes to her 3rd attempt. There's 2 bad oranges left over out of 10 possible oranges. Now she comes to her 3rd attempt, where she can pick out a good orange. There's 8 good oranges, but there's only 9 oranges left over. So this is our calculation. So if we work that out on our calculator, we get 8 over 495. And that is our final answer. Question 17, OABC is a parallelogram. We're told that the vector OA is equal to A and the vector OB is equal to B. Now there's a bit of a typo there. That should be 2B, as shown on the diagram. The point X divides AB such that AX to XB is equal to 3/1. The point Y is 1/3 of the way from B to C. Part A says write an expression for the vector O to X in terms of A and B. Okay, so we're trying to work out this vector here from O to X. So the first thing we need to think about is the vector A to B. Now we can take this magnitude here, and because we know that the ratio of A to X to B is 3/1, the length of A to X is going to be 3/4 of the vector of A to B. And that means the length of X to B is going to be 1/4 of the vector of A to B. So to get from O to X, we can go from O to A, and then we can go from A to X, which we know is 3/4 of AB. But first we need to work out what AB is. So AB is going from B to O to A. But first we need to work out how we get from A to B. So to get from A to B, we go from A to O to B. So we can write that as A to B is basically the same as saying O to B minus O to A. So in other words, A to B is equal to 2B minus A. So to get from O to X, we're saying that the vector of O to X is equal to the vector of O to A plus 3/4 of the vector A to B. So our vector O to X is equal to the vector O to A, which is just A, plus 3/4 of the vector A to B, which is 2B minus A. So we can expand that and simplify it. So we get A plus, now that's going to be 6/4 of B, which is 3 over 2B minus 3/4 A. And then we get the vector O to X equals 1/4 A plus 3 over 2B. So that is our final answer for O to X. So it's 1/4 A plus 3 over 2B. Part B says prove that OXY is a straight line. Now, OXY is the vector O to X plus the vector X to Y. So let's write that down. So vector O to X plus the vector X to Y. Okay, well O to X we know, we worked that out in part A. X to Y we're going to need to work out. So you should be able to see that X to Y, the vector X to Y, is 1/4 AB plus the vector B to Y. Because OABC is a parallelogram, then the side of OA is parallel to the side of BC. So the vector BC is going to have a magnitude of A. So the magnitude of BY, if we're told that the point Y is 1/3 of the way from B to C, it's going to be 1/3 of A. So we can say that xy is equal to a quarter vector a to b plus a third of a. So if we simplify this, we get a quarter of the vector a to b, which is 2b minus a, plus a third of a. And that simplifies to a half b minus a quarter a plus a third a. And that all simplifies to a half b plus a 12th a. Now, in order to prove that OXY is a straight line, well, I said here that it's made up of the vectors O to X and X to Y. Okay, well, we're going to need to prove that both of these vectors, O to X and X to Y, have the same direction. Now, they could have different magnitudes, that's absolutely fine, but if they have the same direction, i.e. they're acting at the same angle, then that means that both of those vectors are parallel. So what we would expect is that the vector O to X is equal to some multiple, let's call it k, of the vector X to Y. That's basically what we're trying to show. So let's compare vector O to X, which is a quarter a plus 3 over 2b, with the vector X to Y, which is a 12th of a plus a half of b. Now, can you see, if I take out a third from xy, I'm going to have a third times something is going to give me 1/12 of a. Well, that is a quarter a. Then plus a third times something, which is going to give me 1/2 of b. Well, that is 3 over 2, or 3/2 of b. So that constant k is a third, because they've got the same direction. They've got this direction of a quarter a plus 3/2 of b. So you can say, therefore, as the vector x to y is equal to a third of the vector O to x, the two vectors are both parallel. They therefore both have the same direction, and we can just say therefore OXY must be a straight line. Question 18 says AOC and BOD are diameters of a circle centre O. Prove that triangle ABD and triangle DCA are congruent. So congruent means they are the exact same size. They've got the exact same side lengths, the exact same angles. So there's a few ways we can prove this. And I think the way I'm going to use is the rule SAS, which stands for side angle side. So two sides I'm going to choose. It's going to be the sides BD and AC. So that's going to be the first one. And the reason for that is we can easily say that the side lengths of BD and AC are the same because they are the diameter of the circle. So side lengths AC and BD are the same as they represent the diameter of the circle. Okay, that's nice and easy, that one. Then the next one is the angle. Now the angle is a little bit more tricky, and the angle that I'm going to focus on is this one. here, and here. So if I call those angles X, what I'm saying is that the angles ABD and DCA are equal due to both of the angles being subtended from the same segment. And that's a law of circle theorems. So if you've got two angles which is subtended from the same segment, and that segment is the segment where we've got A to D. So can you see there I've got a sector here which would be ABD, and then I've got another sector which would be ACD. And because both of those angles are touching the circumference of the circle, we can say that both of those angles X are going to be the same. So that's using one of our laws of circle theorems. And the last side I'm going to use is the side AD. Now the side length AD is a common side which both triangles share, and this represents a chord of the circle. And from writing those three statements, we have proven that the triangles ABD and DCA are congruent, because we've looked at the sides AC and BD, we've looked at the sides AD, which is a common side that both triangles share, and then we've looked at those angles which I've marked X. So that's question 18. Question 19 says a big wheel is modelled as a circle with centre O and radius 15 metres. The wheel turns in an anti-clockwise direction. The lowest point on the wheel is 2 metres above horizontal ground. C is a point on the wheel, h metres above the ground. Angle COB equals x. Show that h equals 17 minus 15 cos x. Okay, so we've got to look at this diagram very carefully. So we're obviously trying to write an expression where h is the subject of the formula. Now, if we look at h in the diagram, you should be able to see that h is equal to the length AB, and that's very important. So h equals length of AB, and that's quite obvious just looking at the diagram. So you can see there that those two side lengths of h and AB are the same, so that means that width of the ground and the width of the triangle AC are going to be the same. So we've got this rectangle just below the wheel. Now, if h is equal to the length of AB, well, that means we can try and find an expression for AB. Now, if we look at this point here, and I'm going to call this point D, because we don't have a point D, that would mean that h is equal to the length AD plus the length DB. Now, DB, you should be able to see, is 2 metres. So h equals AD plus 2 metres, okay? Now, what you're probably saying is, well, we need to work out what AD is. So how are we going to work that out? Well, this wheel is obviously a circle, and O to C, we're told, is the radius of the circle, which is 15 metres. So that means that the radius OC is equal to the radius OD, because they're the same radius. So that means the length of O to D, so O to D must equal 15 metres. Now an O to D is equal to O to A plus A to D. We've got a triangle which is OAC. Now using that triangle, and we're told that there's an angle of X, and we've got our hypotenuse of 15, we're going to have to work out the length of OA using trigonometry. So we can say that OA all over the hypotenuse, which is 15. So we're basically saying that this side's the adjacent, this side's the hypotenuse. So we're saying adjacent over hypotenuse is equal to cos x. And then what you can do is you can multiply both sides by 15 to get the length of OA. So OA equals 15 cos x. So now, up here, we said that OD equals OA plus AD. Well, we want AD because we said here that H is equal to AD plus 2. So we can rearrange this expression here and make AD our subject. So we're going to get AD equals OD minus OA. And what we're doing is we're basically taking the radius of the circle and subtracting it from the adjacent side of that triangle, the length OA. So if I write here, AD is equal to OD, which is 15, minus OA, which is 15 cos x. Now I just need to replace AD with 15 minus 15 cos x. So I'm going to get H equals 15 minus 15 cos x plus 2. And that simplifies to H equals 17 minus 15 cos x. And that is what we had to try and prove. Question 20. Here is a circle, centre O, and the tangent to the circle at the point P is 4, 3. On the circle, find an equation of the tangent at the point P. Right, so to find the equation of the tangent, we know that the tangent is a straight line. So it's going to be in the general form y equals mx plus c. Now, the key to this question is working out the gradient. Now, c we can work out later once we've got the gradient, because we've got a point P which we can substitute for our x and y values. The gradient is a little bit more tricky. So what I'm going to do is I'm going to draw the radius of this circle, and I'm going to connect the centre of the circle to the point P. Now what that means is to get from the centre to that point P, I've had to go along 4 units parallel to the x-axis, and I've had to go up 3 units parallel to the y-axis. Now what that means is that the gradient of the line OP, so the gradient of OP is equal to the change in y divided by the change in x. Well, that's just 3 over 4, it's just 3/4. Now, we're not interested in the gradient O to P, but it's going to help us a lot when we want to try and find the gradient of the tangent. Now, using your laws of circle theorems, you should know that when a tangent touches a circle at a particular point, it is perpendicular to the centre of that circle. So the tangent at a particular point on a circle is perpendicular to the center of that circle. Okay, that is crucial to answering this question. So what we're saying is that the line OP is perpendicular to the line of the tangent. Now, if they're perpendicular, then what that means is their gradients are going to be the negative reciprocal of each other. So remember, when you're trying to find like the normal to a curve, you take the negative reciprocal of the gradient of the tangent. And that's exactly what we're doing here, but we're taking the negative reciprocal of the gradient of the line OP. So what we can say is that the gradient of the tangent is equal to the negative reciprocal of 3/4, which is minus 4/3. Now, using y equals mx plus c, we can replace m with our gradient, which is minus 4/3, so it's going to be y equals minus 4/3 x plus c. And we need to work out what that constant c is. That's our y-intercept. So we can work that out by substituting the point P into this equation. So 4 is our x value and 3 is our y value. So we're going to replace y with 3. and we're going to have minus 4 thirds, and we're going to replace x with 4. So we're going to multiply that by 4 and add c. So we simplify that, we get 3 equals minus 16 thirds plus c. And then if we add 16 thirds to both sides, we get c equals 16 thirds plus 3. So if you work that out on your calculator, you get 25 thirds. And then we can just replace c with 25 thirds from our equation. So we're going to get y equals minus 4 thirds x plus 25 thirds. And that is our equation for the tangent. And that is the final question on the paper. Thanks for watching the video, guys. Don't forget to subscribe to the channel if you haven't done so already. Make sure to also check out our website at www.easymaths.com, where you can find both the exam and mark scheme to this paper.